to get to know Cam and be able to ask some questions. Well, I'm really excited to introduce to you our speaker today, Bill Eggertson. So after working in journalism and with the Canadian Chamber of Commerce, Bill switched to what he calls the correct sector in 1985 as the executive director of the Solar Energy Society of Canada, after the federal government terminated support for renewable energies. Since then, he has worked with the Canadian Solar Industries Association, the Earth Energy Society of Canada, Environment and Climate Change Canada, the Canadian Association for Renewable Energies, International Ground Source Heat Pump Association, and the UK Foreign Office on Climate Security. As well, he has written for Renewable Energy Focus and SolarAccess.com magazines. And he does have some spare time, and hard to believe with all that he's done. In his spare time, he served on a number of energy and environmental advisory groups for the City of Ottawa and IESO in Ontario, as well as trained under Al Gore's Climate Reality Initiative. He was selected as a torchbearer for the 2010 Winter Olympic Games. He also renovated his former personal residence into the top 20 energy efficient home, into one of the top 20 efficient homes in Canada. He graduated from York University and did his graduate degree at Carleton University. He's also been involved with us here at Concordia University of Edmonton, in a number of capacities since 2020. That same year, he formed Net Zero Plus Canada to promote some basic concepts in the energy and environmental space, which will be the basis for his presentation today, titled 4 Crucial Concepts for Renewables. Before I pass it over, to remind everyone on here, this seminar is being recorded, and after the session, we'll open it up for some Q&A. Bill, over to you.
Thank you so much, Carla, and thank you to everybody on the call for your interest in renewables. I've been involved with the sector, both energy and environment, for 40 years. It's growing. It's doing quite well. It's not exploding the way I think it should have. And I'm going to gloss over and not make any mention of the current political environment in Canada and some of the countries around us and what that could, the implications there for renewables. I'm just going to go to pretending that isn't existing and that we still have a trajectory that we must follow. So what I'm going to do is suggest 4 marketing tools that will help advance the adoption, the acceptance of renewable energy, try to get us to where we all think we want to go, and how do we get there quickly. So I'm going to load some slides and share this screen. Let's see if this works. The first step is to understand why there is confusion and the semantics around renewable energy. And part of it is because we have quite a few words that imply the same thing. I'm not saying any of these are correct or incorrect, but this is where there is a little bit of opportunity for some people to squeeze in that perhaps they shouldn't be squeezing in. And we need to get a little bit more clarity on that. Another problem we've got is, what exactly is included or not included in the term renewable energy? I like throwing up these terms. If we were to use the word clean, does that include nuclear? Does that include a number of these others? Again, I'm not going to comment on this at this stage. It's just, this is one of the problems that I think consumers, even regulators, have, understanding what it is we are actually talking about. So we almost need to define where we stand, the parameters, and then move forward with that. So today, what I want to do is discuss 4 crucial concepts that I think are necessary for our sector to advance, that will help people understand it. The 4 verbs I use are label, focus, rank, and count. In combination, these will provide clarity and transparency and accuracy to the use and adoption and uptake of renewable energies, which hopefully increases our accountability and leads to the right decision. through the course of my conversation this afternoon, I will be confusing or mixing energy with environment. I'm only going to deal with secondary energy because very few of us have that much power or suasion over primary energy, and with scope 1 emissions from emissions point of view, because again, very few of us can influence what's going on with scope 2 and scope 3. So the first challenge is to address the basic problem that no one really understands energy. We all think we do, but if you were to ask people what is energy, how is it rated, how is it classified, how is it identified, how is it aggregated, you get terms like this that they all mean the same thing. They are types of energy, usually for a specific source, but they tend to increase the amount of confusion that we get. So we need a common ground. We need a consistent labeling for all energies that will allow comparison. And obviously, if we assume that there is going to be an ongoing evolution or transition to electrification, kilowatt hour is the obvious solution. All of these terms can be converted into kilowatt. The federal government NRCan site posts everything in petajoules, so I take that data and transfer it into whatever form I want, kilowatt hours usually. But this is, if we were to do this, people, again, don't understand what a kilowatt or kilowatt hour is, but they think they do, and that would increase our ability to get our message across. Throughout the presentation today, I will also argue that we need to use the term kilowatt hour, and not megawatt or gigawatt or terawatt. And I'll explain why as we go on. But we do need to become unilingual in our terminology. It's not a question of us learning to speak what the big guys speak. It's a question of getting the big guys to speak what we speak. We also have a number of challenges in terms of other definitions. These terms all mean different things to different people. We need to, as much as possible, get people to understand what they mean. And certainly in terms of capacity and output, that's another one where people say, oh, this is an X kilowatt capacity. Well, what is the output? How much energy am I getting from that rated unit? So let's move on to the second concept, which is focus. I want to look at the major applications of consumption and of emissions. The federal government provides data on 5 end-use sectors: residential, CI, industry, agriculture, transportation. This is all, as I say, secondary energy. If you convert to billions of kilowatt hours, this is how much secondary energy is consumed in each of these 5 sectors. For those of you who like petajoules, and I should admit that when we are going to kilowatt hours, I'm a metric fan. I would prefer that we stick with joules, but kilowatt hours, or kW, is more understandable to most people, but I've put the PJ column in there just in case. So in terms of billions of kilowatt hours, the residential sector consumes 16% of all energy in the country. The commercial institutional is 14. That's a significant amount of energy that is used by those 2 sectors. If you take the thermal load, and by thermal, I'm talking about heating space, cooling space, and hot water. So the 3 applications that are not lights and appliances, or plug load as I call it, 81% of the energy used in your house is for those 3 thermal applications. If you add the amount for residential and offices, it's 22% of all energy used in Canada. 22% is for heating and cooling buildings. If you take the 2460 billion kilowatt hours, the source for that energy is about 25% coming from electricity. So 628 billion kilowatt hours, 25% from electricity. Now, of course, you then have to look at what are the sources of electricity, because electricity is not an energy, it is a carrier. And you look at the number there of that 628, 377 billion kilowatt hours comes from hydro, 36 billion kilowatt hours from wind, and 3 billion kilowatt hours from solar. If we deal with the emissions in all of these 5 sectors, again, I've converted to billion of kilograms, which, no surprise, is actually what a megaton is, but it's 55 in the home, in homes, and 50 in offices, but 450 billion kilograms, or pounds if you're into that, and showing the percentage per sector. Again, I'm breaking off into the thermal applications so that 18% of all energy emissions created by the use of that secondary energy, 18% is for heating and cooling our homes and offices. What are the implications? Well, in the residential sector, there's 15 million households, 37 million population in Canada, and a bunch of square meters of floor space. So for each household, thermal end use consumes 21,000 kilowatt hours a year, whether that's oil, gas, coal, propane, electricity, batteries, or the rats running on the treadmills, whatever it is, it consumes 21,000 kilowatt hours a year. Remember this datum because it comes back later on. That same household, and a household is any living space. It can be a 400 square foot unit or something the equivalent of Mar-a-Lago. But each household on average emits 3,200 kilograms a year just from those three thermal applications. Each person is responsible for 1,300 kilograms a year, and each square foot of residential floor space emits 2 kilograms per year. I used to have fun. My house, as Carla mentioned, was rated as one of the top 20 in the country. Our last house rated as one of the top 20 in the country for energy efficiency. So the local environmental group did tours, and I loved having a floor tile, a 12 by 12 inch floor tile. I would put a 2 kilogram bag of icing sugar on top and explain that for every square foot, every floor tile in your house, on average, you are emitting this amount of carbon. It's a pity icing sugar is white. It should be black. That would have had a bigger impact, but what the heck. So that is the implication for each house. It also explains why I prefer us to use the term kilowatt or kilowatt hour, because you can then divide by a whole lot of numbers and people still will understand it when you get it down to this level. It makes it much easier. So now that we know what is consumed and how it's consumed and where it's consumed, let's talk about why it is consumed. And our association has started a campaign called the Rule of 3C. It is a shameless ripoff of the old 3 Rs of reduce, reuse, recycle. And it's virtually the same concept, but in terms of energy, conserve is your first step. Close the windows, turn off the lights when you're not home. Don't waste. Second is convert. If anybody here is still using incandescent light bulbs in their house, I think I probably need to have a chat with you. Convert to the most efficient system possible. And then once you have stopped wasting and become most efficient, whatever the final demand is, should be supplied by clean. Again, I couldn't put renewable because then I'd be in conflict with the 3 Rs. So it had to be clean. Goes back to my earlier slide saying, the terminologies are not fixed, they're not defined, but it's the intent that clean energy is better than dirty energy. There needs to be more emphasis by the renewable energy sector. We've bought into the more. Everybody's, obviously, it makes money. Conservation is, unfortunately, I guess, a non-money making operation, because what you're doing is you're saving energy, so you're saving money. Renewables on the supply side instead of the demand side. We make money by making more wind turbines and solar panels and ground source heat pumps and whatever. But we have to stop getting into the treadmill of calling for more. Let's make sure that what we need is sufficient to meet the need. Once we get into the discussion of more, if indeed we were to want as a society, and we should, to take care of people around the world, if we were to give everybody else in the world the level of energy that we use right now in Canada, there are huge implications for the exploitation of mineral resources, a whole lot of stuff. Even if it is clean and there are no emissions, we are digging up awful lot of our earth in order to meet that need. So we have to look at the long-term implications of what's going on. In terms of dispatchability, in terms of batteries and the whole issue of lithium, well, where are we getting the lithium for the batteries? Transmission in time of use. There are a number of things that we need to worry about. The final portion I want to deal with, or the final verb, is count. The renewable energy sector must aggregate and verify its production to provide greater transparency, not only will that increase interest support for our technologies, but it will also stop a lot of the greenwashing that's going on. I want to digress for 10 seconds and talk about an industry sector that doesn't seem to quite understand how to sell itself, and that's the heat pump industry, both ground source and air source. They don't quite, and I've spent 15 years in the ground source industry, they don't quite understand what they do. They say they transfer because transfer is a nice verb. If you have ever seen the schematic of a ground source system or an air source system, there is no transfer there. That is production. When I started in solar energy 40 years ago, this was before solar photovoltaics. And in those days, the only solar was passive solar, solar air heating, and solar domestic hot water, which was transfer. You put a tin out in the yard, you let the sun hit the water or hit the tin, heated up the water inside. There's a thermosiphon effect that transfers the water, pumps it around without a pump. And that was clearly transfer. There was no electromechanical operation. A heat pump is the antithesis of that. There are so many phase changes there with heat exchangers and blowers and compressor and reversing valves. The term is produce, and the industry needs to start saying that. The industry also needs to stop saying it is energy efficient. It's not. A house needs 21,000 kilowatt hours a year of thermal energy. A heat pump provides 21,000 kilowatt hours a year of thermal energy. It is dispatchable renewable energy. There is a need for the coefficient of performance, or SEER. You need the electricity to run it, so that is the only way you could argue it is energy efficient. But you are still pumping 21,000 kilowatt hours of heat into my house that will slowly leak out. And what are the implications of a quadrillion houses leaking 21,000 kilowatt hours a year of heat into the atmosphere? It is something you need to be aware of, and they might as well get credit for doing the right thing, but let's count it so that everybody can see how good we are. Other issues that they don't push is the fact that new construction, you can install a ground source for the same price as, almost the same price as an air source. And this invisibility is underscored by the fact that the Parliament Hill in Ottawa is installing one of the largest ground source heat pump systems in the country, and nobody knows about it. There has been no coverage. I went down to Parliament Hill and asked 3 tour guides, hey, what's behind that scaffolding? I don't know. The information officer inside said it's a new system of heating the buildings. How does it work? I don't know. And at this stage, they have no intentions for any sign to say that we are spending a whole lot of government tax money on this system, but it's a good thing to spend it on because it is producing X kilowatt hours per year of renewable energy. Just to close off this one, if all households in Canada put in ground source or put in heat pumps, it would consume 315 billion kilowatt hours. That's how much they would produce that we need. The energy needed to run them would be about 100 billion kilowatt hours. That's assuming it's the worst installation possible. So it's 100 billion kilowatt hours, which is more than double what wind and PV currently are contributing to the grid. In terms of emissions, if all of this energy was, if the heat pumps were run by clean energy, it would reduce emissions by 48 billion kilograms per year. I now have to convert this to 48 million tons because the federal carbon price in 2021 was $40 a ton. If all of the 48 million tons received the carbon price in 2021, that's a revenue stream of $1.9 billion a year. Something to think of. So again, in summary, the production in a house is 21,000 kilowatt hours per year from the heat pump. The house consumes 11, so it needs 6,000 from the electromechanical running the heat pump, plus 5 for lights and appliances for 11. 21 to 11, which I'm going to round off at 2 to 1, makes it a net zero plus. That was the basis for the creation of Net Zero Plus. So in conclusion, This has been an opportunity to suggest 4 areas where the renewable energy sector can and should and must work together. We need to label all energy so that there's common, consistent understanding of what's going on. Then we need to focus on the low-hanging fruit. Then we need to rank the low-hanging fruit before we eat it. And then if every kilowatt hour is counted, the sector can take the pole position in transparency, accountability, and appeal to the public. Carla, back to you.
Thank you very much, Bill. Very much appreciate that very insightful talk. At this point, I'm going to invite members of the audience to ask their questions. And I'll ask you by please raising your hand, and I will go in the order that questions come. Yes, David, thank you. I agree. I'm going to do that as well. All right. Anyone have a question? Hello, Cam. And hello, Waldine. Thank you for joining us. Cam, the floor is yours. You're on mute, Cam. We cannot hear you.
How about that?
Perfect.
Sorry for the finger trouble. Bill, congratulations. My question is, how do we get the word out? This is so sensible, and yet the heat pump industry is not that big, and yet we're just not getting it, to say nothing of the rest.
I suspect that part of the problem is we are competing against renewable energy technologies. For every kilowatt that wind puts up, potentially that means solar puts up 1 kilowatt less. What we need to do is cooperate, and if there is government support for low emissions and not digging up tar sands and stuff like that, again, why shouldn't we get a wind and solar consortium to power a ground source heat pump district heating loop on, let's call it Parliament Hill? If the feds were to get wind and solar power to run the heat pump that they're installing on Parliament Hill, that would be the cleanest operation going. You know, that's the type of thing we need, is this synergism, this working together. I can't generate electricity for my site, but somebody else can. And then you can get into the whole district energy sharing, whatever. So it is a difficult challenge, Cam, because I think we have our little piece of turf, and nobody wants to give up any turf because they think it will lose in the end run.
Yes, you're right. But by the way, just and I should have been in touch with you. I passed on your thoughts to the Chief Protocol Officer of Canada, the Usher of the Black Rod, and he's very enthusiastic about doing something about it. Greg Peters is the person.
I shall bug you after this call.
All right. Thank you so much, Cam. There is a question in the chat from Jake Muffley, and Jake writes, for new buildings, is there anything that can be done to help make houses more ground source heat pump or air source heat pump ready, even if not initially installed, with which is probably a more difficult sell?
Air source can be new or retrofit. I mean, obviously anything retrofit is a bit of a pain. Plus, as a retrofit, you by definition are replacing your gas furnace or whatever you had there. Ground source is very different. That a new subdivision, and it was almost that when I started in this industry, one of my members in the ground source industry, his father was setting up a development east of Ottawa, and we pitched to his dad, hey, we've got the backhoes and the bulldozers on site. Can we just dig a couple of trenches in everybody's backyard before we landscape this division and throw in ground source? me, the ground source dealer, said I would install the units, and if he gets 10 houses, whatever, it was a discount. The dad could raise the price of the selling retail price by X. So the dad won, the homeowner won, everybody won. And we tried pushing that through the city, and we were boycotted by, I forget what it's called, I think the natural gas industry, because that would remove the need, the necessity, and the desirability for expanding gas pipelines. So on new construction, if you don't consider, and again, Parliament Hill, they were installing a new visitor center down below. So some bright spark, and I had nothing to do with it, said, hey, let's drill a couple of boreholes and do it in there. So that was an obvious time to install the system. Ground source, yeah, on a retrofit at our last house, it was a retrofit. I did it. So I learned how to use a backhoe and dug up the backyard. My wife's screaming at me because, the flowers are in danger, blah, blah, blah. It can be done, but it is more expensive to do it. New is a no-brainer. And air source, again, it's always best to do it at the start. You can size it properly. You can position the outside compressor on an air source so that it's not next to your neighbor's bedroom window, because in summer, that's a real pain in the butt. There are design and bylaw issues that need to be considered, but it can be done. We just need to have a desire to go the correct way.
Thank you, Bill. Another question from Tim Street in the chat box. It says, sorry for such a basic question, but can Bill please clarify the difference between primary and secondary energy?
To totally oversimplify, primary is the digging up of drilling of oil, the digging up of coal, the production of the energy that is going to be reformed, refined, converted into other things. Secondary energy is literally what is dumped off at your house. The gas that goes into your car is secondary energy. So it's literally the upstream primary is upstream, secondary is the usable commodity that we deal with in our homes and offices and cars and agriculture.
Sorry, some technical issues there. Thank you so much, Bill. So I'm going to invite everyone to either raise your hand or type your question in the chat. And we have another one now from David Wilson, who's asking, why do you think the HVAC industry does not want to get organized to support heat pumps?
Most of my career has been association management, trying to organize people. So this is a very sensitive question to me. I've never understood why people who are in an industry or a sector or an aspiration, and they're working together. Yeah, they are stealing each other's potential market profitability. That's a bit of a concern, but something where there is nobody in competition. Why can they not get it together? I think it's largely lack of caring, lack of time. Consumers don't understand. I mean, consumers are, with all due respect, they don't know anything. They ask for two dealers to come up, say you need this size of gas furnace or heat pump or coal furnace, and they don't know what are the implications. We need to do a better job. And I think if we were to, a little bit like the environmental movement, I've been involved with that, and there's a lot of very, do-gooder type people who mean well, whether they achieve anything. But I think the industries need to get a little bit more cooperative, collaborative, whatever, together. And we need to develop a little bit of synergism with promoting the same objective. And that would make us work closer together to say, hey, I can lend you my backhoe, or hey, I know a solar guy who will install panels on your roof at X cost, whatever. We just need to get a little bit more synergistic with our efforts.
Thank you, Bill. Before I go to the next question in the chat, I have a couple for you. One is, you mentioned right off the offset in your presentation that we should all be speaking the same language, and you're suggesting we talk in kilowatt or kilowatt per hour language. Why don't we speak the same language currently?
I always bring up the question, people who rate things in BTUs, 10,000 BTUs, and I ask somebody, do you know what a BTU is? And it's a British thermal unit. No, but do you know what it is? Not what does it stand for? And it's the amount of heat emanated from the striking of a hardwood match. So this is very relevant to today's time, but we still use BTUs because we are set in our ways or lazy or whatever. Again, oil people, it's easy to do barrels. That's how they were moved. It was by barrels, and they would put it in barrels. Natural gas is cubic meters because it is a gas. So you can't put it in a barrel. You have to put it in a pressurized pipeline. So there are different ways of measuring, but the what's it called? The efficiency of the burner tip on a gas means that that cubic meter of gas is going to give X amount of heat or 2X amount of heat, depending on its efficiency. Same thing with anything you burn. So it depends an awful lot on the efficiency. Why we haven't converted? Because we are all, our own backyard. I'm used to calling it barrel of oil, cubic meters, whatever. That's going to be the way it goes, because what's the incentive for me to go to kilowatt? And that's why I'm saying the renewable energy sector can classify everything we do with all of those technologies as kilowatt. Let's get the big boys to come down to our level or up to our level and use the same terminology so that everybody from consumer and regulators and politicians and utilities, we all are talking the same language.
Thank you, Bill. Our next question is in the chat, and it comes from Jeff Passmore. It says, hello, Bill. Do you know anything about water furnaces? Our house has had one for 30 plus years, but it runs off electricity, and I'm not convinced it's efficient or saving any money.
I knew the head person at Water Furnace for a number of years. They were one of our major companies with most of the associations. They've largely converted over to GeoSmart, which is it's a ground source heat pump. And that was the system I installed in my house, which of course my last house is the one that you can see in the background that was rated in the top 20. We had a ground source in there. Again, it was oversized. And whenever I tell that to anybody in the industry, they go snake, because no, it's got to be right sized. I did the digging. So there was no cost for a deeper loop and longer loop. It meant that I never had to turn on the emergency backup. It was turned on for 10 minutes every fall, simply to burn the dust off the filaments in case there had been a problem. And it was there in case there had been a power failure. When power comes back on, if the ground source hasn't worked for a week, you're going to want electric resistance to heat up your house pronto. But water furnace, have a dealer check it out, Jeff. It should be saving you money. If it's that old, maybe, I'm assuming you've cleaned your filters, that there's no blockage in the loop, that everything, that it was right sized to start with. There is no reason why it should be failing. One of the largest sites in Canada is the Museum of Canadian History. Again, lobbied the federal bureaucrats there for ages. Could you please put a sign outside saying this building, we've all been to the Museum of Canadian, well, many of us have been to the Museum of Canadian History, beautiful building. Put a sign outside saying this sucker is heated and cooled by renewable energy. What are you talking? Yeah, again, bureaucrats, with all due respect, don't necessarily understand that. They need to understand the appeal to taxpayers by saying that. But back to Jeff's point, have a dealer check it out. There are ways of assessing the efficiency, and they should be able to diagnose that you've either got a dead rat stuck in your loop somewhere, or you haven't changed the filter, or there are quite a few things that you have to check, as with any technology. But it should be working, and ours in the last house worked extremely well for, I think, 7 years before we sold.
Thank you, Bill. We have another question in the chat from Tim Kuzak. Tim asks, to what extent, if any, might Alberta consider use of small nuclear reactors? I'm originally from New Brunswick and grew up about an hour away from Point Lepreau nuclear plant. Seemed to work well in New Brunswick. Might this work in Alberta?
60% of Ontario's electricity is nuclear generated. So we're the largest province. Manitoba, BC, and Quebec are largely hydraulic. Alberta is still gas primarily. At least you're off coal out there. But nuclear works, and it's a good, ignore the scope 2 and 3 emissions from the concrete necessary to put it in. Ignore the fact that they have still not been able to figure out what to do with radioactive waste. I think we still ship it off to Indonesia and drop it off the side of a boat there. There are some problems. They won't melt down the way, whatever that famous movie was, 3 Mile Island. And small nuclear is better. I mean, I tend not to like nuclear on its costs. Its life cycle cost per kilowatt hour output is higher than what it should be. Solar panels or wind turbines with batteries usually are cheaper. Alberta has a lot of good solar and wind resource, but I mean, nuclear is fighting in there. And are they clean? Are they green? Are they renewable? Wow, I don't want to touch that question.
Thank you, Bill. Does anyone else have a question? Feel free to raise your hand or type it into the chat. And while we're waiting for the next question, I have another one for you, Bill.
Shoot.
You mentioned that in Ottawa, at specifically Parliament Hill, they're installing a heat pump to provide the building with heat. Are you aware of such initiative in any other public building in Canada at all? Or is this the first kind?
The Museum of Canadian History, the largest private operation is Deep Lake Water Cooling in Toronto, where the vast majority, I can't remember the data offhand, but they take the water from Lake Ontario, pump it into commercial buildings in downtown Toronto. So X%, it was a large percent, need cooling. Commercial buildings need more cooling, space cooling than they do space heating, so air conditioning basically. And they take the water from Lake Ontario, run it through, cool down a number of buildings, and then they sell the water, which is now warmed up, to the what's called the water utility. So that's a very large, it's water source as opposed to ground source, but the same concept. It's the largest private, but in terms of public, no, I'm not aware of it because it frequently costs more and the bureaucrats don't understand the cost savings, or they are capitulating to a lobby group called, let's call it the gas industry. Things like that. There are reasons why government doesn't do it. And you would have to explain to taxpayers that we're spending money, potentially more upfront than something else for the good. And that's the pitch that we're doing with the Parliament Hill is you're spending this amount of money to do something good. Get credit for finally doing something good.
Thank you very much, Bill. One last time I'll ask, I haven't seen any hands come up. We do have one more question here from Matt Terry. How many offshore, I'm not sure what WF means.
Wind farm, probably.
Wind farms, probably. Does Canada have spending to GDP, and where are they? Here in the UK, we are building hundreds for the 2030 target. So Matt, I'm assuming, is contacting us or is joining us from the UK.
And I don't have a good answer for him. I know we do have some offshore wind farms off the East Coast, one or two off the West. And again, size, once you put in more than two wind turbines, it becomes a farm as opposed to a standalone. So we do have some, but not nearly as many as we should. Certainly on the two coasts, we've got very strong winds. My daughter lives up in Inuvik, and I've been up there. They have wind farms up there. Again, small turbines, and they're not offshore. They are onshore because all the rest of their electricity is by barging in or trucking in oil to burn to generate the electricity. So we are way behind the UK. We're behind a large number of countries because we just haven't had the, incentive. It's cheaper to produce by nuclear or gas or hydro. We haven't had the need as places like the UK have. They don't have an awful lot of other sources of electricity, so they have to get into the right ones, the new ones, such as wind farms.
Thank you so much, Bill. We have two more questions, three that have come into the chat, and these will be the last three that we take, just because of the interest of time. The first one comes from Henry Agura. Do you have any idea what the opportunities for thermal storage and heating up north, and are there federal government grants for these?
I know there are grants. I don't know how extensive. The potential is phenomenal because, again, thermal is the majority of your energy requirements in terms of residential and commercial, and they don't have that much industry up north. So storing the sunlight, through into batteries, or storing thermal by heating up the water and then just keeping the hot water around until you need it. So you're using whatever is cheap / natural / abundant / good to heat up the stuff. There are, as I say, rebates or incentives or assistance. It's tricky because you're keeping literally hot water is the majority of it. It can also be cold water, but not in northern Canada. So hot water, you need to have an insulated thermos bottle, so to speak, and you pour the hot water in when the kettle's there, and you wait until later on before you make your tea with it. It's very practical, it's more expensive, and it requires people to use energy in a slightly different way. I mean, down here, we don't have to worry about dispatchability. We use electricity whenever we want to. It's got nothing to do with wind and solar because somebody is backstopping us. But thermal is a little bit, it's more challenging.
Thank you,
Could
Bill.
I just add, Bill, that a closed loop ground source heat pump is a thermal storage device. You're storing energy you've used in the summer, 2 or 3 months, that when you switch over to winter heating, you're actually heating from the ground that was heated by by your summer cooling. But for the north, there's a really interesting opportunity, and that is to build a house or build any building on permafrost. The heat from the building will melt the permafrost, and your second-story window will be your entry point. But if you put a ground source loop underneath the building before you build it, you can save thousands and thousands of dollars. The current state of affairs is to build on gravel that you have to dig up from somewhere and move and put in. There are all sorts of technologies, but by heating the home, you're cooling the ground and thereby preventing your building from melting into the permafrost.
And to Cam's point, yes, that underscores why it's not being done that much, because he has to explain. I mean, why do they not teach this in schools? Why do utilities not promote it? Why do the various governance agencies not say, hey, this is an option up north, instead of trucking the oil up there? This is why the industry needs to get its act together and promote a synergistic approach to cleanness in Canada.
Amen to that.
Thank you. So we have a few more questions. Another one from Jake, and it's asking, do you have any thoughts on municipalities requiring homes to be built solar ready? And if so, solar ready to what extent, i.e. roof angle, aspect, protrusions, optimally placed, etc.?
Yes, I have. Boy, he shouldn't ask that question because that'll cause us to go into overtime. Yes, I mean, that was part of what I did working on the Ottawa Advisory Committee, trying to get the city of Ottawa to understand, if you make houses with a south-facing roof and a slope of 37 degrees, like my last house, it was 1 degree off true south and 1 degree off the azimuth angle for optimum solar. And I don't know if the guy who built the house knew that when he was doing it, but all city buildings should be designed so that they can accommodate not just solar, not just wind, but also ground source. So solar is an obvious one, and solar is the sexy technology. I mean, let's be honest here. And yes, so why should roofs not be oriented towards the south on the right angle with no trees planted, deciduous trees planted in front of them? It's a no-brainer, but that's where we get government, is no brains. So.
All right. We have a comment from David saying commercial developers are sharpening their pencils and realizing there is a good total life cost. And last question, and then we do have to wrap up. I know some folks have other commitments after this. From Tim Street is asking, does Bill have a view on how green the use of biomass, to create energy is? Either biomethane production or burning waste to produce electricity?
If there is waste, it has to be disposed of, and I would rather burn it and capture energy than send it over to Indonesian landfills, which is the current way we're doing it. So yes, how do you manage and mitigate the amount of emissions coming from that? Can you capture that? So there are quite a few. Anything that combusts has downstream problems, in my opinion. But let's look at how to either capture those noxic gases as they're emitted and somehow do something with them. We're getting into carbon storage, which sort of works as long as nothing disturbs it. Biomass works. Biomass was the first renewable energy. Cavemen burnt stuff. What is the wood or the forest source? If it's waste, that's better. Can you take that heat and use it for a good application and send it to somebody's house, whatever. So there are quite a few downstream questions that need to be answered. But if it's green biomass and you define green and define biomass, then I'm totally in favor of it.
All right. Thank you, Bill. We do have some folks asking to connect with you afterwards. So what we'll do is I'm going to put our email address on here. Please send us an email address and we will forward those requests over to Bill, and we'll connect you that way. We're not going to publicly share Bill's email here, but we will connect you if you do wish to connect with him after the seminar. First off, please, if I can have everybody, whoops, sorry, the lights go off if I don't move in my room. I want to just ask everybody to please join me in thanking Bill for his presentation. Very excited to have started this seminar series with Bill. And I just want to share with everybody that our next session is scheduled for Tuesday, February 25th at noon Mountain Time. And our speaker will be Jeff Passmore from the Passmore Group. So next week, you will all receive in your inboxes more details about this talk. So once again, thank you all very much. This session is being recorded, and so we will be posting it, and feel free to visit it again. Thank you all. I wish you all a wonderful rest of your day. See you all in February. Thank you.